My name is and I'm a master's student in mechanical engineering at Clemson University, and this semester I took the Advanced Composites Manufacturing course at ICAR with Dr. Pilla, and part of the course was a project that was given to us where we were asked to build something out of carbon fiber. And my background as far as my hobbies go is cycling, so I've been riding bikes for about 8 years. Part of those years I raced bicycles, and in most racing bicycles a lot of the parts are made out of carbon fiber reinforced plastics, and that was my initial interest in the course. I wanted to know how are these parts made? How is a carbon fiber bicycle frame even made? So that's why I took the course, and in the course we went over all of the modern manufacturing processes for carbon fiber parts. So when Dr. Pilla assigned us this project, my mind immediately went to bicycle parts, and so I started thinking about what could I make, right, that would be easy enough for me to make in a semester, but that in the end, I would have something that I could keep, that I could use. So I decided to build a bicycle saddle out of carbon fiber. And so I began by drawing some models in SolidWorks. I measured some saddles that I already had and kind of played with the geometry till I found something that I thought looked cool and I think would also be comfortable and fit my personal physiology. And then I started 3D printing some prototypes. Initially I wanted to make a mold using a 3D printed saddle, and as I kind of iterated through my process and tried different things, I ended up printing a negative mold of the saddle. So this is the negative mold, and this took about 32 hours to print. I printed it in the makerspace at Clemson. We have access to 3D printers, and so I used that to make the saddle, the upper surface of the saddle. So this is the saddle, this is what it looks like once it's finished. And a saddle is mounted to a bicycle with some mounting rails. So underneath the saddle there are these mounting rails, and those were the most challenging piece to build. I actually also used 3D printing to make those, and so there's a 3D printed part inside this. So it has a 3D printed core, and the 3D print by itself is really weak, so you could easily snap it like a twig. But once the carbon fiber is cured on there with the epoxy resin, it becomes extremely strong and stiff. And so this saddle actually I have mounted to my bicycle, and I've ridden on it already a couple times, and it's pretty amazing how strong it becomes. So one thing I learned is that it's not as easy as it looks. I think it was pretty challenging to get the parts to come out right, to make sure that there aren't any voids in the laminate. So I made 5 of these upper pieces, and only 2 were good enough to use. So when I signed up for the course, I didn't actually realize that there was going to be a big project as part of it. So I was just interested in learning about how carbon fiber was made, but when I found out that there was a lab portion where we actually got to observe different processes and also make stuff ourselves, I got super excited. I've always been a creative person, and I like doing things with my hands, so when we went down to the lab for the first time to make some trial parts, I was super excited, and then over the course of the semester I was coming to ICAR a lot to build pieces, to build my parts, and to try new things. So that part was a lot of fun, the hands-on part, which is something you don't get a lot in graduate school. Definitely a pipe dream career would be to work in a bicycle company on like bicycle frame development or something like R&D in cycling. That would be my dream career. Maybe with this project now I'll have something that I can attach to my resume and that will differentiate me from the crowd when applying, because for sure those kinds of jobs are popular among engineers who are also cyclists.